Hello everyone, welcome to a new video. In this video we will learn about applying linear regression in Python. Linear regression is a powerful statistical technique used to model the relationship. By the end of this video you will have a solid understanding of linear regression and be able to implement it in your own data science projects. We will be using NumPy, Pandas and Matplotlib for this tutorial, and we will train our model with scikit-learn library. At the first stage, we are going to import NumPy, Pandas, and Matplotlib. Now let's create a simple dataset to work with. For the purpose of this tutorial, we will generate a synthetic dataset using NumPy. Our dataset will have two variables, the independent variable x and the dependent variable y. Firstly, we are going to create x with a curvely spaced values using linear space, and we are going to generate 100 random noise values. numpy.random.normal 0, 1 and 100, and now we are going to generate y values using a linear equation with some noise like 2 multiplied by x plus 1 plus noise. I think we are good with this. Here we use the linear space function from NumPy to create 100 accurately spaced values between 0 and 10. We then generate 100 random noise values from a normal distribution using numpy.random.normal. At the last step, we create our dependent variable y by applying a linear equation to the independent variable x and adding the noise. Visualizing the data is crucial to gain insights and understand the relationship between variables. So we are going to do a visualization application here with using Matplotlib. Let's plot our dataset using it. We are going to use scatterplot, and we are going to say x, y, color, let's say blue, and we are going to give the label of data points. Let's close this, and we are going to say x label, y label. Now we are going to add a title. We are going to say legend and use plt.show here. We can see that our data is pretty suitable for linear regression. We use the scatter function from Matplotlib to create a scatter plot of our dataset. Each point represents a pair of x and y values. The x-axis represents the independent variable, while the y-axis represents the dependent variable. Adding labels, a title, and a legend helps make the plot more informative. Now that we have our dataset, it's time to implement linear regression in Python. We'll be using the scikit-learn library, which provides a simple and efficient implementation of various machine learning algorithms. For this, we are going to say from sklearn.linear model import linear regression, and we are going to use x equals to the x.reshape -1 and 1, since we want input to match the expected shape, and we are going to create the model here with linear regression. And then we are going to use model.fit, and we are going to fit this to our data, and just run this for now. Let me fix the typo, and we are good to go. We trained our model. Now we are going to extract the coefficients. For this, we are going to say slope is going to be equal to the model.coefficient, the first index of it, by using 0, yes. And the intercept is going to be equal to model.intercept. And we can just set this and print slope and intercept together. So our model is something like that. Y is equal to the 1.26 plus slope multiplied by x. Our linear regression model have this formulation. We import the linear regression class from scikit-learn and reshape our x variable to match the expected shape. Next, we create an instance of the linear regression model and feed it to our data using the fit method. Finally, we extract the slope and intercept coefficients from the trained model. With our model trained, we can now make predictions on new data points. Let's generate some test data and see how well our linear regression model performs. Let's create new test data points. X test is going to be equal to the numpy dot array, and we're going to create an array here. Let's say 2, 4, 6, 8, and 10, and we are going to use that reshape method. And now we are going to make predictions on the test data. We are going to say predictions is going to be equal to model.predict x test, and let's print the predictions. Predicted y values, and we are going to say predictions. Let's run this and see what's the output. I'm sorry, I made a typo there. Let's just use this with capital letter, and as we can see, we got the predictions from our model 5, 9, 12, 16, and 20. Here we create an array of test data points and reshape it to match the expected input shape. We then use the trained model to make predictions on the test data using the predict method. Finally, we print the predicted y values. To better understand the model's predictions, let's visualize the regression line along with the original data points. We are going to say plt.scatter, and we'll pass x, y, let's say blue for color again, and data points for label, and we are going to say plt.plot x model.predict x, and for this time we are going to use color red and label regression line. Let's set x label and y label. We are going to set title also as linear regression. We are going to use plt.legend, and at the last step we are going to say plt.show. We plot the original data points using the scatter function as before. Additionally, we plot the regression line using the plot function. The regression line represents the best fit line that minimizes the difference between the observed and predicted values. This line serves a predictive model for future data points. That was all for this video. Thanks for watching. Have a great day.